welcome back. We're going to take a look at method 2. Method 2 was using the back of the book, Appendix 4, to calculate the overall Gibbs free energy change of a reaction. That answer, if it's exergonic, meaning if delta G calculates to be negative, will tell us if the reaction is thermodynamically favorable. If this reaction calculates to be positive, then it's endergonic. And we're going to know that this reaction is not thermodynamically favorable. So I just want to go over this just to reiterate that it's simply from Appendix 4. Now, on a College Board test, you will not get the appendix. Most often, they will supply it to you as a data table. So I've already collected my data. I've got that right here. This is called methanol. That's his delta G. Oxygen. Take a look at that. The Gibbs free energy value of oxygen, because it's elemental, that should make sense. No work needs to be done on oxygen if it already looks like oxygen. Carbon dioxide, here's his delta G value. Water has that delta G value. Notice that I had to use the delta G of the gaseous state because that's what's in the reaction. Take a look at it right there. So you have to be very careful about which state you're choosing. Let me show you in the book, just the 3 columns again. Delta H of formation, delta G of formation, and delta S. Look at the units here, because these are 2 energies. They're kilojoules per mole, because this is entropy. It's energy change per every unit of Kelvin. So it's a little different than these 2. All right, how to solve the problem. I'm going to set this up just like we do any other formation problem. So we're going to go, sorry, I don't know why it's not. We're going to say that delta G is equal to the sum of the delta G of the products minus the sum of the delta G of the reactants. Okay, we're going to take and add this together. We've got 2 CO2s that we need to worry about, 4 gaseous waters. Close that down, subtract that away from the 2CH3OH plus the 3 oxygens. Tell you what, I'm going to let you work that out. Please try it. Please work it out. Get your answer. I'm pretty sure it's something like negative 3,000. I was just looking to my teacher answer notes. I'm pretty sure it's something around negative 3,000. All right, method 1 is the equation that we have not done yet together. Remember, this is method 1 from the other page. Delta G equals delta H minus T delta S. There is a trick that I want to show you. These problems are so straightforward, right? If I know delta H and I know temperature in Kelvin and I know delta S, I should easily be able to calculate delta G. So what's the trick? Well, one trick I already taught you. The delta H and the delta S have to be in the same joule or kilojoule unit. That's essential. But this problem that I'm going to share with you right now has another secret to it so that you have to be aware of. That secret is that the delta G of a phase change is equal to 0. And the reason it's equal to 0 is because if you're at equilibrium with the liquid state and the gas state, then there's no preference of which direction the reaction can run. In other words, at 0 degrees Celsius, water can melt or water can freeze. It just depends on the input of direction of energy. So if I have 0 degree, ice, but I start to add energy to it, it's going to melt. If I have 0 degrees ice and I start to take energy away, it's going to stay frozen. So the delta G of the phase change is always set equal to 0. So take a look at this problem. It says, at what temperature is the following process spontaneous at 1 atmosphere? Essentially what they're asking is, at what temperature does bromine naturally begin to melt? So for water, this answer would be 0 degrees Celsius or 273 Kelvin. Because that's when it spontaneously starts to melt. But this is bromine, so it's a different substance, so we're going to search for this answer. At what temperature is the following process spontaneous at 1 atmosphere? What essentially is the boiling point of liquid bromine? That's what we're asking here. What is the boiling point of liquid bromine? Here in the problem, delta H is equal to 31 kilojoules per mole. Delta S is 93, and I'm pretty sure I have a mistake here. I'm so sorry. I'm pretty sure. Let's check. Pretty sure this should be in the book under bromine. Oh, no, it's not the right one. Boo to that. Pretty certain we got to make this a joule, that this is 93 joules, so take that off. Okay. So, one thing we can talk about is, should we make the kilojoule a joule or make the joule a kilojoule? Let's go ahead and turn this into 31,000. Sorry. 31,000 joules per mole. Okay. So what we're going to do is plug in and go delta G is equal to delta H minus T delta S. I'm going to take delta G minus delta H, and that's going to equal negative T delta S. At this point, I know that this is 0, delta G of a phase change. We've got liquid bromine becoming gaseous bromine. That's a phase change. Delta G is equal to 0, so we're going to have negative delta H is equal to negative T delta S. My delta H is 31,000, so it's just going to be negative 31,000 joules. Is equal to negative T times delta S, so that's a 93. That's going to remain 93 joules. This is a kilojoule per mole. This is a joule per mole. Okay, so how would we approach this problem? I'm going to take and divide each of these sides by negative 93. So let's do that. Divide this side by negative 93. That's going to equal... Oh, and divide this side by negative 93. Look at the negatives cancel, the 93 cancels. What I end up with is, let me grab my graphing calculator real quick. I've got negative 31,000 divided by negative 93. And my answer comes out to be positive 333.3 Kelvin. So what did I just learn? I just learned that the boiling point of liquid bromine will happen at 333.3 degrees Kelvin. And for those of us that care, that would be 60 degrees Celsius. Hope this helps. Major point. So when you're doing your homework, when you're doing chapter 16 homework, remember, delta G during a phase change is 0, and that's how you're going to solve that problem. Because you might think, I don't know, I wasn't given all the information, but you were. Watch out for that. Please text me or remind me with any questions that you have. I hope this helps. Good luck.